So far, we have learned about a variety of data types. While the focus of these lessons has been the C programming language, I want to emphasize that these lessons are applicable in every programming language. Fundamentally, we learned that every number, as well as every character of text, is encoded in binary in a certain way and then stored in memory. We learned that you can specify exactly what type of format you wish to use with certain keywords, such as signed or float. We learned in a previous lesson that the number of bits you have available for a number determines how big of a number you can have. For example, if you are limited to 3 bits, you could never have a number greater than 7. Each data type has a set size in bits. This also means that each data type has a maximum number it can hold. If you are using a sign bit, then there will be a maximum positive number and a maximum negative number it can hold. Figuring this out is actually quite simple. There are 3 possible cases to consider. The 3 possible cases to consider are unsigned, signed, or float. In this lesson, we will be looking only at unsigned data. If a data type is unsigned, that means that it will only be positive numbers. This is easiest because figuring out the maximum size is simply 2 to the power of the number of bits and then subtract 1. Alright, so let me explain why this is. It might seem complicated at first, but it's actually extremely simple. So if you have 3 bits, the maximum value you can store is 7. Why is that? Well, because with 3 bits there are 8 total possibilities you can store, but one of those possibilities is 0, because we start counting with 0, and then we work our way up to 111, which is 7. So when you are counting in base 2, which is binary, first you have your ones place, which is 2 to the power of 0. Then you have your twos place, which is 2 to the power of 1. Your fours place, which is 2 to the power of 2, and so on. Now this is the same thing as in base 10, except in base 10 you have your ones place, which is 10 to the power of 0. You have your tens place, which is 10 to the power of 1. And then hundredths, which is 10 to the power of 2, and then thousandths, and so on. It's just that we're working with base 2, and so instead of it being 10 to the power of whatever column that we're in, it is 2 to the power of whatever column that we're in. So here's what I want you to see. If you have 3 bits, then if you want to know what is the maximum value you can store in 3 bits, you simply say that 2 to the power of 3 is 8, and then 8 minus 1 is 7, and therefore you know that with 3 bits you can store a maximum value of 7. If you have 8 bits, then you would say that 2 to the power of 8 is 256, which means you could store 256 total possibilities. One of those possibilities is 0, which means the maximum number that you can store is 255, which is 2 to the power of 8 minus 1. So notice that this table of 2 to the power of the number of column also lets you know what the place value for that column is. First we have the ones place, then 2, 4, 8, 16, and so on. So if you have 16 different bits and you want to know what is the maximum value you can store, you just simply plug 2 to the power of 16 into your calculator and subtract 1. So let's take a look at this in action. If you have a numeric data type which is contained in 2 bytes, that is 16 bits, then the maximum number of possible values is 2 to the power of 16, which is 65,536, which means that if you started at 0, and started to count upward, the maximum value you could ever actually get to is one less than this, which is 65,535. Now, keep in mind that whenever you are working with different data types, whether it is C or any other programming language, there's always going to be a minimum and a maximum value, and that minimum and maximum value is always going to be determined by the number of bits that a given value is being stored in. So there are tables you can find for different programming languages that tell you, okay, if you're using a short int that is unsigned, you can go from 0 to 65,536, but you don't even need to use those tables if you simply understand how to figure this out yourself. So just remember, it is 2 to the power of the number of bits. That tells you how many total possible values you can store, and if you subtract 1 from that, you get the highest possible number you can store. So if you are limited to 16 bits of storage, then the maximum value you can store is 65,535, which means that every single binary digit you have available to you, all 16, have been set to 1, which means the hexadecimal value for that would be FFFF. This is another way of saying that with the value 65,535, we have used up all of the available 16 bits available for storage, and we simply cannot hold a larger number. You may wonder why you need to know this, and the answer is very simple. Anytime you ever have a mathematical calculation in your program that exceeds the maximum value of a given data type, your program will fail. In later lessons, I will go into the specifics of what these limits actually are. Remember that the maximum values, as well as the size in bytes of each data type, may differ between compilers. There are, however, certain requirements that all compilers must follow. We will explore that in greater detail later on.